Hi everybody, welcome to our today's tutorial, and today our topic is LTE capacity optimization. But before I go deeper into the details, I would like you to subscribe to our channel and also press the bell icon, because that will help you notify of our new videos. And at the end of today's lecture, we will also be giving you details about our upcoming online optimization course, which covers the entire scope of optimization in LTE. So let's begin with LTE capacity optimization. And the main factors in LTE capacity optimization, or you can say in some way we can also refer to as throughput optimization, are your reference signal SINR, then your PDCCH capacity, then your PUCCH capacity, then you have your specific parameters and procedures for downlink throughput or data rate, then you have your separate procedures, parameters for your uplink throughput, and then basically we can look at spectral efficiency and some other factors that affect LTE capacity. So let's dig into our LTE capacity lecture and start with our first topics. So our first topic is reference signal SINR, that is your RS SINR. Basically your reference signal SINR will play a very important role in terms of your LTE capacity, your throughput performance in the downlink, and your overall network structure, because this is the resource element that basically enables the mobile to detect the cell signals and basically then perform any other actions in terms of that. Also it will affect your CQI, and the factors affecting your RS SINR can be your coverage, basically it can be your downlink interference, it can be your terrain, it can be your clutter, it can be your grid issues or anything. But RS SINR is a very important factor, and you need to optimize it in order to optimize your capacity. The next factor, which is some people say it as the heart of LTE and the way LTE provides the shared throughput to its user, is the PDCCH. PDCCH capacity is extremely important in LTE because PDCCH provides you this DCI, that is your downlink control information. And in downlink control information, you have all the information regarding the grants when a particular user has been granted resources in downlink, or when a particular user has been granted resources in the uplink. Also it gives you information about the acknowledgement for the hybrid retransmission. It also gives you information about other factors. So there are different formats for this DCI, that is we have 0, 1, 2 and 3. This is basically the 0 part is for your uplink grant. Basically if you have been granted a resource in uplink, then you have your 1, that is for your downlink, that you have been allocated a resource in downlink. Then 1 is divided into basically there's 1A, which is for preamble, for your pre-ratch, then 2 and 3 basically defined for different other downlink mechanisms. How PDCCH capacity is calculated, that is also a very interesting aspect. PDCCH capacity is usually calculated in terms of CCE. CCE is your control channel elements. So I will explain you in terms of LTE resource block how CCE works. Basically PDCCH has 4 formats, that is 0, 1, 2 and 3, and these PDCCH formats then correspond to a particular CCE format. So basically you have 1, 2, 4 and 8. So it's CCE, 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 CCE. So if we are using PDCCH format 0, we will have one control channel element. If we are using format 1, then 2 for 4, then 3 for 8. So basically you can aggregate these control channel elements to provide the PDCCH information. And in each CCE we have 9 resource element groups, and in each resource element group we have 4 resource elements. Now what do you mean by resource element in LTE? Resource element is basically your OFDM symbol, in time domain mapped onto a subcarrier. So basically this is how PDCCH information is mapped onto your CCE. So what happens in LTE, that if you have PDCCH congestion, for example, you have used up all the PDCCH resources, then you cannot inform your UE regarding an uplink or downlink branch. So even if you have resources in in your downlink shared channel, then you will not be able to inform the UE regarding any data that needs to be transmitted either in the downlink or in the uplink. In terms of calculating how much resources we need to allocate for PDCCH and these CCEs, and there is some thing called PDCCH boost. We will go through another lecture, but this is how PDCCH works, and this is how PDCCH capacity impacts LTE's throughput in general. And if you go into further detail into PDCCH congestion basically will cause direct impact onto your bitrate. Then we have our PUCCH capacity. That is your physical uplink control channel, and physical uplink control channel also affects your throughput, because there are 4 formats for this as well, like 1, 2, and 3. So in the first format you basically have your scheduling request. In the second you have your CQI, that is your channel quality indicator, and in the third part you have other different elements included into it. But if you see, if you have your PCCH capacity issues, you cannot have a scheduling request sent to your E node B, or you cannot have your CQI sent to the E node B. Now what parameters we usually optimize in terms of handling your PCCH capacity? So we have a parameter which describes how many physical resource block you allocate to this CQI format 2. Then we have our time period, periodic. So we have periodic time period for SR, for scheduling request, and basically for CQI. And the default idea is that we use 10 millisecond. Per 10 millisecond we have one SR and we have one CQI. We can change that parameter as well if we see that the radio conditions are not that basically feasible. And coming back to PDCCH as well, in PDCCH we have 2 aspects. One is your common channel, and then is your user specific. And when what LTE specifications have done is that this common channel is limited to these 2 formats to basically ensure that they have better radio performance, and the user specific can use all the 4 formats. So this was something about PDCCH capacity, PUCCH capacity, and RS SINR, and now we will move on to basically what are the factors that impact your downlink throughput, and what are the factors that affect your uplink throughput. Let's see what we have for downlink data rate optimization and uplink data rate optimization. First we will discuss uplink, and we will go from what are the issues and how we basically resolve or optimize them. Number one issue that can come in downlink throughput is your high blur. Blur is your block error rate, and that is the main you can say KPI on which the entire LTE coding and rate adaptation, code adaptation and modulation adaptation works. Blur is mostly caused by when your UE is in low coverage area, and your coverage issues can be caused by a number of factors. That can be parameter optimization, that can be coverage optimization, that can be anything. Then you have your bad CQI, and bad CQI can result from coverage issues, that can also result from downlink interference issues. Then you have your scheduling algorithms, then what kind of scheduling algorithm you are using. Number 4 is your PDCCH and PRB high resource utilization. So if you are running low on PDCCH and on your resource block resources, your utilization will be higher, and any utilization above 80% will cause you throughput issues, and that will cause you cell throughput issues as well, and user specific throughput issues as well. Then you have your transmission modes. We have three transmission modes usually. One is called your single user MIMO, then is your transmit diversity, and then is your multi-user MIMO. So all of these, then you have your single input multiple output CMO mode as well. So all of these transmission modes basically provide you with different kind of data rates. For example, in diversity you have the same data being transmitted through multiple transmission ports, and in your multi-user MIMO you have your spatial multiplexing, and your data rate is much higher. But these have specific SINR targets, and in order to optimize your network so that your connection do not have radio link losses, and also you have the maximum throughput, you need to optimize those SINR thresholds to switch from one transmission mode to another, and you must have your dynamic switching on as well. Another aspect in downlink throughput, as we would not be covering the entire aspects in this short video, but another aspect which we can check in the network is how much of usage is on 64 quadrature amplitude modulation. Because the higher the modulation schemes, higher the data rate you will get. And if your CQI is consistently in the bad region, so for example you have this normal distribution, and this is your basically majority of your CQI is in the bad part. So this will in result, as per the code and modulation adaptation, you will not have your majority of the users on high modulation schemes, and therefore your spectral efficiency and your data throughput will go down. So we need to check these kind of things for your throughput. And second is your TCP and UDP impact as well. Most importantly, if you're having a TCP low throughput in your drive testing, you can check and use your UDP, and if you are have improved results in UDP, then you need to check your TCP settings as well. These are some of the factors that impact on your downlink throughput. There are a number of hardware factors which can also impact on your downlink, and the parameters that include in downlink are, as I told about, the SINR thresholds. Then you have your scheduling scheme parameter, then you have your format indicator parameter, then you have your power control parameters. So these are the parameters that you may use to optimize your downlink throughput. Then we come to our uplink throughput, and in uplink throughput we have similar problems such as blur and bad CQI. Then we have scheduling issues, and majority of those issues are basically related similar to coverage or your uplink interference and stuff like that. Some of the parameters that we can use in uplink are related to your uplink power control, and that is your P naught nominal for your uplink control channel, or P naught nominal for your uplink share channel. Then we have our fractional power control factor alpha, and we have also got our fractional factor for the proportional fair scheduling scheme. So these are the this is a very brief summary of the throughput factors in LTE, and definitely you will need to work in detail to get to the bottom of the issue and apply the knowledge accordingly. So now I will let you know about the LTE training, the comprehensive LTE training that we will be publishing, and we will be publishing it in the third week of March. And you can visit our website, which is given in the video detail section, and have a look out on the third week of March, and that video will be available online. It will be several hours of optimization training for LTE, and it will be the only training of LTE available online at a very minimal cost. So we want everybody to learn LTE, optimize it, and also have it at your doorstep. So subscribe to the channel, hit the bell icon, and keep looking out for new videos from our channel. Thank you so much for your time. See you next time.